Okay, in this video I just want to take you through the process of core reduction, moving from a single platform core through to a rotated or multi-platform core, where we can see in this case all our flakes go from a single platform, and in this situation the flakes are coming from multiple platforms and from different directions. So that would be our multi-platform core, and this would be our single platform core with one surface. And with single platform cores, we would define this upper surface here as our platform, and all the flakes will go in one direction off that. So I can show you that process now, striking off a piece of silkcrete. And all the flakes that come off this will have similar properties. They'll all have this single platform surface on top here, big old conchoidal scar, or else the cortex. And as you can see, as I'm working into this core now, you can see that the area available for flaking is getting smaller and smaller. Until we reach a point where there's actually really not that much available surface left at all. There's maybe just enough for one more flake there. And that's it. So all of our flake scars go in one direction off this now very small platform, and our flakes that we struck off also show those same features. All the flake scars are in one direction, sometimes with some cortex left on the bottom there, and the platform will just be that surface that we've been flaking, so that old scar on the surface. In some cases there might also be a bit of, quite often there'll be a lot of cortex on the surface as well. So typically with this kind of single platform core reduction, you start to get a build-up of step or hinge terminations. Overhang removal will further reduce the available platform area, and at that point we end up with a platform which is very small, and an edge angle which is quite steep, and a lot of hinge and step terminations, which means we really can't progress with core reduction on that surface anymore. And in this instance we can't really move around the outside very much either. Maybe in some cases we might have been able to continue flaking around the outside, but we can see the edge angles and the irregular surface is not suited to that. So at this point, flint knappers or prehistoric stone tool makers would rotate the core, and to do that they would now look around the core for another available surface. So here's another surface that we could probably take a few flakes off. And so here I'm just doing a bit more unidirectional flaking, but we soon find I've exhausted that area as well. I've now got hinge and step terminations along that edge, the edge angle's about 90 degrees, and the available surface area for the platform is very small. So we need to rotate the core again. And now perhaps what we'll end up doing is using this old surface that has a lot of overhang removal and step terminations. This now becomes our platform. And the edge angles there are quite steep, but maybe we can still take some big flakes off. So here's a flake, here's another flake, and we can see straight away a characteristic feature of the flakes struck off a multi-platform core, and that is now we can see the surface, unlike our earlier flakes which just had a single plane surface on them. Now our platforms have multiple scars on them. So we have a dihedral platform with some faceting, which is actually the overhang removal from the old platform edge. And much like our flakes off our single platform core, because we're on a new platform now, we're picking up some cortex on the dorsal surface as well. So let's keep flaking that platform for a bit. And notice the same problem is occurring. We're getting step terminations along the edge and we're running out of available platform area. And our flakes that are coming off have got, again, lots of scarring on the platform, indicative of having once been an old flaking surface. Okay. There's not many more flakes we can take off here, so we're starting to reach a point now where we've got step terminations here, step and hinge terminations here, step and hinge terminations here, So we've now got 1, 2, 3 platforms, 3 directions of flaking. So this is a rotated core or a multi-platform core. Let's see if we can take any more flakes off. So this was one of our old platforms. We're now going to use this surface that we just flaked to strike back the other way. So we're rotating the core again. You get 1 or 2 more flakes off, but that's about it. We've reached the limit of that platform as well. And at this point, flint knappers might continue to try and strike off more flakes, or they might continue to rotate the core until all the surfaces are worked and there's a lot of flaking over all the available areas, or they might discard that core at this point. Now I just wanted to show you another characteristic type of flake that actually appears when we flake our multi-platform cores, and that's called a redirecting flake. So something that can happen when we are flaking these multi-platform cores is that when we change the orientation of flaking, we can actually sometimes take off a flake that preserves the old platform edge. And this is called a redirecting flake because it shows us that at some point the direction of flaking has been changed. So just imagine we've been, as you can see here, we've been flaking this platform for some time, and then maybe I strike off a flake from this point here. So I change the orientation of the core. I'll actually attempt this in a second. And then I take off a flake that preserves that old platform edge on it. That would be called a redirecting flake because it's redirecting the orientation of force of the blow. So let's see if I can get a flake off, for instance, along this edge that will take off a nice big redirecting flake. Okay, so the flake has cracked, but we can see that this flake that I struck off preserves the old platform edge. So here was the platform previously, and flake scars were taken off in this direction. Now we have a new flake going in this direction, and our redirecting flake has come off, and we can see, here's the ventral surface, along that dorsal ridge we can see old initiations. So we can see the old crushed points, and the direction of flaking has changed. That's what we mean by a redirecting flake. So I can see if I can take off another flake of that kind on this core now. Let me see if I can find a good spot. Maybe if I can take a flake off that will take off this platform down the bottom here. Okay, there we go. So this is a much bigger example now. This flake I've struck from the top here, and you can see preserved on the sort of distal part of the flake an old platform edge, which was the base of this core. In fact, it's taken off 2 flakes here. So let's have a look at our redirecting flake. Here's our cone of force and our bob of percussion. That's the ventral, nice fissures and everything. And on the dorsal side, we have flaking in this direction, as well as flaking from an old platform edge here. So that's a classic redirecting flake. Now, one last feature that we sometimes find on a core is, this is actually a good example of it that I inadvertently struck off, and that's called a tablet flake, where you might try and strike off a big area of the platform in order to create a flat surface that rejuvenates the entire platform. So sometimes those tablet flakes will actually clip the edges of old platforms around the outside. This one hasn't exactly done that, partly because we took off this flake prior to it. But if we can imagine that these 2 things were actually one large flake, the tablet flake, that would have rejuvenated the entire surface of the platform. And that could be done, you know, elsewhere on the platform as well. If I struck a big flake here and struck off this old platform surface here, flattening the top of the core, then we'd end up with a classic tablet flake at the top. It's something that we see a lot in blade production, for instance, where, you know, having struck off a series of long thin flakes around this platform edge, step terminations start to appear, and then the napper might strike somewhere along this edge just below these crushed initiations in order to rejuvenate the entire platform surface. I doubt my hammerstone's big enough to do it, but I'll just see if I can. Okay, so actually we did manage to do that pretty well. And we've struck off a whole series of platform initiation points around the top. We can see it mainly actually just right next to the platform here. And this has rejuvenated the top of that platform. So that's these classic flat tablet flakes that we find associated with platform rejuvenation. So that's the majority of features we'll be discussing in the next few weeks associated with core reduction. So the single platform and the multi-platform cores, the redirecting flakes and the tablet flakes.